In this technical support video, I'm going to be discussing how we can take a standard Fred lens element and turn the plain bevels that you get by default into something that's more typical of a lens, like a chamfered beveled edge. So let's start in Fred by creating a singlet lens. I'll define it by focal length and bending, so we're going to make it a biconvex lens. Give it some thickness, 8 millimeters. Down here in the lens aperture specification area, I can choose from some advanced settings here. So my options are I can give a standard circular elliptical edge without bevels. In that drop-down list, I can also select edge with front and back bevels. Now here I'm going to go ahead and specify the outer edge, that's the full diameter of the lens element. We'll make it 20 millimeters in X and Y. I can also specify the aperture of the front and back optical surfaces. The difference between the outer edge and the optical surface apertures will become a beveled surface. So we'll make this 19 on both sides. So I should have a 1 millimeter edge bevel here. Hit OK. I'm going to hit apply now. We see in the 3D view that our lens has shown up. If we zoom in, this is the 1 millimeter flat edge bevel. And what I'd like to do is take that flat edge and turn it into more of a chamfer, so we'll give it a 45-degree angle here. So if I expand out my lens element node here, I find that I have the edge surface, which is a cylinder, the two optical surfaces, and then these two plain beveled edges. So we're going to open up one of our beveled surfaces here, change the type from a plane to a cylinder, and click yes. I'm sure I want to do that. The aperture of our cylinder in the front starts at 19 in X and Y and goes out to 20. Remember, it's 1 millimeter in height. Hit apply. Now I need to adjust the depth of the bevels, the cylinder surface here. So I go to the aperture tab. I like to use the min-max specification. It starts at 0, goes out to 1, so it has a length of 1 and a height of 1, and I hit apply. If I zoom in here, here's our 45-degree tilted bevel surface. We're going to do the same thing for the rear bevel surface. Change it from a plane to a cylinder. Yes, I'm sure. The front end now is going to be 20, so it's decreasing in height. The back end goes to 19. The Z location is going to go from -1 to 0. Remember, the bevel is starting at the plane of the rear surface here. So hit apply. I go on the aperture tab. I'm going to adjust the Z depth, so it's going to go from -1 to 0. Hit apply. So now if I zoom in on the edge of my lens element, you see I have this excess surface here that we need to get rid of. So an easy way to do that is to use the surface trimming specifications. So I opened up the edge surface dialog, and I'm going to go to the aperture tab, and we're going to enter some surface trimming specifications here. Now remember that by default Fred uses the surface normal Z positive as the direction of which I'm going to trim away a surface. So for the cylinder surface here, if I zoom in, the surface normal for the first bevel is pointing down and to the right on the screen. So that's Z positive. So if I enter here, select entity, bevel 1, hit OK. Now hit apply. I'm expecting this side of the edge surface to be trimmed away because that lies along the positive Z surface normal. Hit apply. That's what I expect to happen. Now what I actually want is to trim away the Z negative. So I'm going to insert in my trimming specification here a knot. Okay. Now I've kept the part that I want to. I need to do the similar operation for the second bevel surface. Remember, pointing inward for the cylinder So now the Z positive lies to the left, so I need to trim away everything that's not in the Z positive direction. So I'm going to do let me move this up. Not, select entity, bevel 2, hit apply. And now I have a simple chamfered singlet. So the second part of this question that came in was, what do I do in the case where I have a single component where the edge height is actually changing? So here's an image of what we're going to build here. This is all one element, except the edge height now has this discontinuity in it. How do we build this part? The thing we have to be careful about here is that the ray or a ray can take multiple paths through this object. So for example, we can enter the first surface and exit out through the discontinuity in the edge height here, this ray number 1. Or we can enter the first surface, travel all the way through the lens, and then exit out the back. Now at this plane right here, we need to account for the fact that a ray can go glass to air and also glass to glass. So there's not an interface if we're in the middle of the lens element, but there is an interface if we're outside some diameter. So how do we build this component? Let's go back to Fred here. I'm going to turn off my chamfered singlet. Okay, I've got a composite lens here, 2 lens elements, and let me turn off the second lens so we can see the system we're working with here. I've got a convex plano lens here of some aperture size. It's 20 millimeters. Okay. The second lens element is a plano convex lens. Let me turn it on. Plano convex lens, its aperture is only 17 millimeters. So to build these, make these 2 lens elements into a single composite, what I'm going to do is, on my first lens element, this back surface here, I'm actually going to use its trimming volume inner hole specification. Right now it's 0. If I'm going to make that 17, which is the full aperture of that second component we're basically going to integrate into this lens element, and hit apply. Notice in the 3D view now that the surface only exists from 17 millimeters out to 19 millimeters. So what we're going to do is use this inner trimming hole, and we're going to fit the second lens element right into this empty aperture space. So let's open it up again. Notice that I've set the starting coordinate system to be surface 2, which is the surface we just modified. So if I turn it on, now that lens element sits right inside that vacated aperture space. Now I need to expand out lens 2, and notice that I have this surface that still exists in the middle of the composite element here. I'm going to go ahead and right click and toggle it never traceable for trimming surfaces. And that means that a ray can pass right down the gut of this composite element, intersecting only the first surface and the back surface of the second element. So there's no intersection in the middle of the element, which means that it goes air to glass, travels all the way through, then glass back to air. And this will account for all of the possible material combinations through this lens system.